G'day and welcome to Sporanza Guesses the Methods exam, the series where I guess the methods exam so you don't waste your holidays and you do some study instead. I've just gotten back from walking the dog, but I don't need that anymore. Let's put that one down there and let's do some maths. We're going tech free this time. We're going to do 2 multiple choice and 2 short response. This is our first multiple choice. Feel free to pause the video now. Let's make that a little bit bigger so you can really see what's going on there. Feel free to pause the video now, work through that question. I'll be back soon. In 3, 2, 1. All right, let's solve it. We've got a function f of x here, and we're trying to find out which of these 4 is f dash of x. Now remember that f dash of x tells you the gradient of this original function. So we really just need to think about the gradient of this function. All right, from this point here and all of this stuff, the gradient is positive, right? We're going uphill from there to there. If we were to go from this side to this side, we're going uphill. So positive gradient. Now, all the rest of this stuff is a negative gradient. If this was a roller coaster, whee, down there. So everything from there to there, negative gradient. But there is one exception. Here is a 0 gradient. And also here is a 0 gradient. So we've got a 0 gradient there and a 0 gradient there. When we go to our 4 solutions, probably the easiest place to look is where these 2 0 gradients are, because the gradients match up with our y coordinates of f dash of x. So a 0 at -3 and a 0 at 0, that means that we should see an x-intercept on our f dash of x at -3 and at 0. So this one's a good candidate. What else might be a good candidate? -3 and 0, -3 and 0. Alright, so the only one that doesn't have x coordinates there is this one. Alright, now we're looking for a positive gradient from -5 to -3, and even before -5. Positive gradient, that means that the y coordinate from -3 onwards is positive. Look here. The y coordinate's not positive to the left of -3. It's negative, so that one's out. Look here. From -3 to -5, it's positive. That's true. But look, beyond -5, so like -6, -7, it's negative. And that's not the case here. If we were over here at -6 or -7, it's still positive. It's positive there, right? Because it's going uphill. So this is not our answer. What about this one? Let's take a look. All right, from -3 and all the way to the left, it's always positive, always a positive y, right? We're not talking about the gradient of this curve. We're talking about the y coordinates of this curve. All right, from here to here, we're below the curve. We're negative. From -3 to 0, we are negative. And then from 0 onwards, we're also negative. So B is our answer for this one. All right, takes a little bit of puzzling, but you really want to look at your turning points or stationary points first, locate those, and then start looking to the left and to the right of those, looking at positive gradients and negative gradients. All right, remember this is tech free. We're doing a binomial random variable. Pause the video now, try to solve it, give yourself 90 seconds, and then I'll come back. All right, here we go in 3, 2, 1, and let's get to solving. All right, it's not an easy question. We've got a binomial random variable, and we're told the expected value equals 2, and the variance equals 4 on 3. You really should go to your formula sheet because you should know formulas for this and this. All right, so 2 handy formulas here for the mean and the variance. So the mean is equal to NP. And we know that the mean is equal to 2. So 2 equals NP. And we know that the variance is equal to 4 on 3. So 4 on 3 equals NP, 1 minus P. All right, so what do we do from here? Well, we can do a really clever trick here because we've got two equations in N and P. And I'm going to do a simultaneous thing here where I substitute 2 for N and P, because this is 2 is equal to n times p, and n times p appears in this formula. Alright, so when I do that, it'll be 4/3 equals 2 times 1 minus p, and then solve that for p. Alright, so I've gotten to solving that. I'll leave you to look at that, but p equals 1/3. That is, the probability of success equals 1/3. Now that we know that, right, we can say that the probability that x is equal to 1 is equal to. A little bit more work to do here, because we knew p, but we haven't solved for the n yet. Alright, so let's sub 1/3 back into equation 1 and figure out what n is equal to. Alright, so I've subbed that into equation 1, solved it, n is equal to 6. Alright, so now I have a p-value and an n value, n equals 6. So I want to know that the probability that x is equal to 1 success from 6 trials. Now, if you go into your probability, into your formula sheet, you'll see this formula here, and we can work from there. So the probability that x is equal to 1 is equal to 6 choose 1, and then the probability of success, which is 1/3, to the power of r, which is 1 times 1 minus p, so 1 minus 1/3, which is 2/3, to the power of n minus r, 6 minus 1, which is 5. Alright, we're looking for something that looks like this. 6, 1, 1/3 to the 1 times 2/3 to the 5. Alright, 1/3 times 2/3 to the 5. What's this 6 doing out the front? 6 choose 1 is equal to 6. There are 6 different ways that you can have 1 success from 6 trials. So 6 times 1/3 to the 1 times 2/3 to the 5, bracket, 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 bracket. Our answer here is D. Alright, a couple of things I want to say about this question. This is probably 5% harder than a question that we might see on the exam, so I might be guessing a little hard here. You might see a question where you're trying to figure out n and p. You might see a question where you know n and p and you're trying to do this. This feels like a little too much. And of course, in the Queensland exams, you're not going to have 5 options here, but I've borrowed this from Victoria and they've got 5 options on theirs. Alright, let's start doing some short response. Alright, so before I get started on this one, I want to give a shout out to Mrs. G from St. Andrew's Anglican College. She sent me this question as a possible question, and she sent me the next question as well. So thanks, Mrs. G, you're a legend. So we're going to say this is worth 6 marks, so it should take about 9 minutes. Pause the video, see if you can answer it. Have a crack. Alright, I'm going to start answering it in 3, 2, 1. Alright, let's go. Now, it's another binomial probability question, right? Because we've got success or failure, tagged cow, untagged cow, and we're going to be going over and over and over again with these. Alright, it says, calculate the probability that the number of tagged cows selected on a given day is 0. So let's make tagged cow a success, right? And the probability of getting a tagged cow, there's 30 cows in total, 10 of them are tagged, so 10 out of 30. The probability of success, P, is equal to 1/3. Alright, how many trials are we doing? Calculate the probability that the number of tagged cows selected on a given day is 0. Alright, 4 times each day. So every day we select 4 cows. Look at them, put them back, look at them, put them back. So we're going to do 4 trials here. Alright, and we want to know the probability that x is equal to 0. So we're going to have 0 successes here. Now that's going to be equal to NR for 0 successes times the probability, we know P, it's 1/3. And we want to have 0 successes, 1/3 to the power of 0. And then we're going to have 4 failures. So 2/3 to the power of 4. Now, where did 2/3 come from? That's the probability of failure, or 1 minus P. 1 minus P, 1 minus 1/3 is 2/3. Alright, 4, 0. There's only one way you can have exactly 4 failures. There's only one way you can do that, and that's fail everything. So 1 times 1/3 to the power of 0, anything to the power of 0 is 1, times 2/3, that's the same as 2 to the 4 over 3 to the 4. Alright, 2 to the 4, 2, 4, 8, 16. And 3 to the 4, 3, 9, 27, 81. Alright, it doesn't look like I can simplify that, so my answer here is 16 over 81. This feels like a really good tech-free question here. It's a little bit tricky, it's got some index law stuff going on. You've got to know 4 zeros equal to 1. This feels like it could very well be on one of these exams. Alright, so we're in tech-free zone, we're doing part B here. Calculate the probability that at least one tagged cow is selected on a given day. Now a lot of you are going to look at that and think, this is tech-free, I can't do at least one, I need like Binomial CDF on my calculator. But the probability that x is greater than or equal to 1 is equal to 1 minus the probability that x is equal to 0, right? Because if you want to get 1 or more than that, there's only one other option, exactly 0. And thankfully, we've already calculated the probability of getting exactly 0. So 1 minus 16 over 81, and then we have to figure that thing out. Now, if you're struggling with fractions a little bit, 1 is equal to 81 over 81, minus 16 over 81. And then you've got to do 81 minus 16, which is 65 over 81. Don't be scared here. If you can't do 81 minus 16 in your head, don't be scared to do go really old school. Alright, don't be scared to do that on a tech-free paper. You might need to do it. Okay, last question. Determine the probability that no tagged cows are selected on each of 6 consecutive days. Express your answer in the form A over B all to the power of C, where A, B, and C are positive integers. Okay, this is not straightforward to me because we've been doing binomial probability on the selection of an individual cow on a day. But this is a different kind of binomial probability. It's the same situation, but we're switching it up a little bit. Because now we're doing determine the probability that no tagged cows are selected on each of 6 consecutive days. So now we're doing a different binomial experiment where we're saying, okay, we know that the probability of getting no cows on one day, no tagged cows on one day is 16 out of 81. So the probability of, which we'll call that success, getting no cows, is now 16 over 81. So forget the fact that I said earlier that P was equal to 1/3, because this P is different to this P. This is the probability of getting a single cow. This is the probability of getting 0 cows in one day. All right, and we're going to do 6 consecutive days, so we're going to do n equals 6. All right, now the probability of getting no tagged cows on 6 consecutive days here, the probability that x is equal to 0, it's equal to, now we're going to have 6 trials, and we're going to have 6 successes, where success means having no tagged cows on a day. 6 from 6. And we're going to have exactly 6 successes. 16 over 81 to the power of 6. And then times, and then it really doesn't matter this next bit, but I'll write it in. 65 over 81 to the power of 0. No failures. Right, there's only one way to get 6 successes from 6 trials, and that's just to not have any failures. So that's 1. And then we've got this 16 over 81 to the power of 6. So we've got 16 over 81 to the power of 6. And we can probably pull up stumps here. We've got A, where A is 16, B, where B is 81, and C is equal to 6. Mrs. G goes one step further though, because she knows that 16 is the same as 2 to the power of 4. And she knows that 81 is 3 to the power of 4 to the power of 6. And we can now write that as 2 over 3 to the power of 24. That's probably a neater answer than this answer, but I'd have to say that the QCAA is going to accept both because we've got an a over b to the power of c in both instances. Great question, and we've got another one from Mrs. G coming up now. Alright, so we've got something with some exponential functions. It's worth 5 marks, so you should give yourself about 8 minutes to do it. Pause the video, give it a try. Alright, I'm going to do it now in 3, 2, 1. Alright, how are we going to go about this? We've got a function, e to the 2x minus 3k e to the x plus 5. So it has a single unknown in it, k, and we want to know what that k value is. So if we could sub in a value for y and for x, and it's got one unknown, we should be able to get that. And we can sub in a value for y and x because we're told that there's a point on the graph on the function 0, 0. So let's sub 0, 0 in for y and for x. So 0 equals e to the power of 2 times 0, so that's e to the 0. So e to the 0, anything to the power of 0 is 1. So 0 equals 1 minus 3k times e to the 0, which is 1. So 3k times 1 is 3k, plus 5. And then solve that. That's pretty straightforward. We can put the 3k on this side. 1 plus 5 is 6. K is equal to 6 divided by 3, which is 2. So we know k equals... Alright, so we figured out one of the unknowns. We need to know a or b. Look at a here, right? So we're told that when y equals 0, x equals a. And we need to know what that is. So let's sub in y equals 0 and start solving. It feels a little bit weird though. So sub y equals 0, or I guess f of x equals 0, same deal. So 0 equals e to the 2x minus 3, not k. K is 2, so we know that, minus 6 e to the x plus 5. Aha! We've got this familiar thing, or at least it should be familiar, this quadratic action, e to the 2x minus 6e to the x plus 5. Now when I see e to the 2x and e to the x in a single equation, I like to simplify it in my own mind by letting e to the x equal u. Alright, so when I do that, I get 0 equals u to the 2, u squared, minus 6 times u plus 5. So we should be able to factorize that, hopefully. It's a monic quadratic, so bracket u, and then we need two numbers multiplied together make 5 and added together to make negative 6. So that's going to be 5 and 1, but not two positives, two negatives. U minus 5 times u minus 1, that is that. Okay, so let's solve those two using the null factor law. So u minus 5 equals 0, so u equals 5. And u minus 1 equals 0, so u equals 1. But of course u is not u is e to the x. So e to the x equals 5 and e to the x equals 1. On this side, e to the x, that's very straightforward because that's got to be 0 there. X equals 0. Now this is not helpful to us because we already knew this. We knew that when y equals 0, x equals 0. It's right here. So the solution that we are looking for must be here. Okay, now we're going to write this in logarithmic form. ln 5 equals x, and there is our solution. When y equals 0, x equals 0, or x equals ln 5. Therefore, a equals ln 5. All right, we've got k and we've got a. The last bit that we really need is this b value here. And it says it has a horizontal asymptote at y equals b. So, think about just like a very basic e to the x. F of x equals e to the x. That function has an asymptote, a horizontal asymptote, at y equals 0, right? Why does it have an asymptote at y equals 0? Because it doesn't matter what value you sub in for x, e to the x can never be negative. If you sub in e to the 2, you'll get e squared, which is a positive number. If you sub in e to the 0.0000001, that's just the nth root of e, which is also a positive number. If you sub in e to the -5, no, let's write that one down because that one's a bit funny. If you write down e to the -5, you're going to get 1 over e to the 5, which is just a very small number. E to the 5 is a big number, 1 over a big number is a small number. My point here is that e to the x can never be negative, right? And you know this. You know that e to the x has an asymptote at 0. So let's consider the actual question that we're dealing with. We've got some other weird function here, right? F of x equals e to the 2x. Now, e to the 2x can never be negative. It's always positive. This one here can never, ever be negative. It's always positive. Now, it can get very close to 0, but never quite 0. So, very close to 0, very close to 0, and of course, this bit is always 5. Our asymptote here is y is equal to 5. Y is equal to 5, therefore b is equal to 5. Now, technically, we can do that whole thing with limits if we want to, but I'm not going to bother you with limits on this question here. I'm going to leave it there with a more intuitive approach to it, I suppose. All right, there we have the graph of the function. We figured out k equals 2, a equals ln 5, and b equals 5. All right, let's keep score. These are all the questions we've guessed so far. If you've missed those ones, if you look on your screen right now somewhere, you should see part 1 and part 2 of this video series. Stay tuned for the next one, like and subscribe. Thanks again, Mr. G. See ya.